All right, so we're going to talk about thermodynamics, and specifically in this video, we're going to talk about conductors and insulators. But first, let's talk about what thermodynamics is, since this is our very first video for the unit. So first, thermodynamics literally means movement of heat. So thermo, the prefix thermo, means heat, and dynamics means movement or study of movement. So heat, study of movement means movement of heat. So here we're going to look at energy moving from one object to another. So thermodynamics is the study of heat, which is just moving energy, and its transformation to and from mechanical energy, where mechanical energy is, again, energy of motion. So here it could be an actual object moving, or it could just be electrons moving in a certain substance. So first, let's talk about conductors. So you might have an idea of what a conductor is already, but more specifically, a conductor is any material that easily allows movement of energy. So in this unit, we're talking about thermal conductors, or conductors that easily allow heat transfer. We'll talk about conductors again when we get to electricity, so electrical conductors. But for right now, conductors overall are objects that easily allow movement of energy. Conductors are usually substances with loosely bound electrons, which means if you look at the inside of the material, these electrons will move from one to the other atoms and will just flow back and forth from atom to atom very easily, loosely bound, so easily moves. The best material that has loosely bound electrons is, of course, metals. So metals overall are very good conductors. Some metals are going to be better conductors than others, and we'll kind of get into that a little bit in class. And so the idea is this energy is put in one end of an object, and the electrons are what move the energy from one end of the object to another. So for example, on a pot. So if you've ever boiled water and it was a pot where the handle could get really hot, well, the heat was at the pot and it moved by electron, particle to particle, up the handle. And so the electrons are what are moving the energy from particle to particle. So the energy is not moving, it's the electrons that are moving to make the energy go from one side to the other. So now let's look at insulators. So the difference is that insulators slow the rate of energy flow. So it slows, it does not stop. You may want to write that down. Slows, not stops. Okay, not stops. Anyone who's ever had a thermos, you know that yes, your soup or your cocoa or your coffee or something like that will stay hot for a long time, but eventually it will cool off. It won't stay hot forever. Hence, slows, not stops the rate of energy flow. This will become very important when we get to electricity and talk about this. And so some examples of some good insulators: air. Because the particles are so far apart, you think about like you're sitting in air right now and you can't see these individual particles, but you know they're there. They're so far apart that it's hard for energy to go from particle to particle, just sheerly because of distance. Another example is wood. Here the electrons are pretty tightly bound. So insulators have tightly bound electrons. And so wood and plastic, those electrons are pretty much stuck with the particular particle, the particular atom that they're with. In air, it's just simply because the particles are not very close together. A vacuum, of course, is a very good insulator because there are no particles. If there are no particles, then you can't transfer energy because energy has to go from particle to particle in terms of these conductors and insulators. So anything like this where you have air pockets, you have plastics, you have wood, anything like that are good insulators. So now let's look at some questions just to kind of get an idea of the difference between conductors and insulators. And of course, it's also looking at how even two insulators, one is better than another. So when barefoot on a cold day, why does a wood floor feel much colder than carpet if both are at the same temperature? So I would suggest writing these answers down so that you have them to look back on. So here we have a wooden floor, so just a hardwood floor, and we have carpet. Because the room is a certain temperature, these two surfaces are at the same temperature. But we know the wooden floor feels much colder on bare feet than the carpet does. So why would that be the case? Think about what you think it would be. Well, it's because carpet is a better insulator than a wooden floor. Yes, wood is an insulator, and it is a good insulator, but it is not as good as carpet. Carpet is much better. Not only does it have the little fibers, which are good insulators, but it also has all those air pockets that squish whenever you step on carpet. So it has different kinds of insulators that are together. So carpet is a better insulator, hence it doesn't feel as cold. Why do metal objects feel colder than non-metal objects? So let's say you open the fridge, right? And there's something that's in a metal container versus something that's in like a Rubbermaid container. When you pull the metal container out of the fridge, it feels colder than the Tupperware or the Rubbermaid container. And the reason why is because metal, again, write this down so you have it, metal is a good conductor, whereas the Rubbermaid or the Tupperware or anything like that, the plastic containers, plastic is a better insulator. So the metal is a better conductor, whereas the plastics are better insulators. That's why the metal feels colder. And then lastly, how does a blanket make you warm? After all, it doesn't create heat. So unless you have an actual electric blanket, that plugs into a wall, blankets do not contain heat on their own. They're regular room temperature, right? When you first get in your bed at night, the sheets are cold. But after a minute or two, it starts warming up and you start getting warmer and you feel a whole lot better because now you're actually feeling warm. Well, the reason why is it's not because blankets create heat. They don't. Instead, they insulate your body's heat. So your body is releasing energy. Okay, that's why our hands feel warm. That's why you can feel really cold when you're outside, is because your body is releasing energy. But this blanket or coats, jackets, things like that, nice sweaters, these are good insulators. And so insulators slow the movement of energy. So the energy that your body releases is then trapped, at least temporarily, trapped by the blanket. So you may want to write that down. So blankets do not create heat. Instead, they trap the heat from your body so that it keeps you warmer.